Okay, so today we are going to look at properties of logs. They call this section logarithmic function manipulation. So what we'll be doing here is we will be looking at how we can take logs and rewrite them in different forms for that. Now, what's kind of new, this was already a topic that was definitely in pre-calculus. I do it every year. Actually, it's not an overlap for Math 3. However, sometimes whenever Coach Wood and Miss Martin teach this in Honors Math 3, they do a little bit of this. So you may have seen it before. I'm not sure. But the properties are actually not in Math 3. You don't have to do them there. I definitely did not do anything extra with my regular Math 3 students. We did only the things that were required. So you may or may not have seen this, but this is different than rewriting as an exponential. This is taking a log expression and writing it either in a condensed form where it's all one logarithm or in separated form where it's several different logarithms. So if I have log base b of x times y, I can apply the product property, which tells me that since these two things are multiplied inside of that parentheses, I can split them into two logs that are added. And we could spend a significant amount of time going over proving why and exactly how that works. But I'm going to ask you guys to take my word for it that this is a proven mathematical theorem that works every time. Because I'll be honest, I'd have to go look up the proof for this to show you guys, and it would take a lot of precious time. You will not be asked to prove that this works on the exam. But if you're really interested, I'm sure you can find somebody on the internet proving this for you if you need to know that. So whenever you have a log, things on the inside of the parentheses are multiplied, you can split it up with addition. Okay? The quotient property is similar, except for you're going to use subtraction whenever you have two things that are divided on the inside. And then the last property is the product property. And the product property tells us that if we have an exponent right here, it can be pulled out as a coefficient. I do want to show you this. The product property is really just the power property is really just the product property shown in a different form. Because let me show you, actually you don't have to write this down, I just want to show you how this works. So like for example, if I have log base 2 of x to the 4th power, right? Let's say I don't know the power property. The power property tells me I can just take that 4, I can pull it out front. This is going to equal 4 log base 2 of x, right? But let's say that I don't know the power property. Let's say that I only know the product property. Well, x to the 4th could be written this way, right? X times x times x times x. You guys agree with that? Okay. The product property tells me that when I have things that are multiplied inside of my parentheses, that I can break those into separate logs that are added together. So I could write this as log base 2 of x plus log base 2 of x plus log base 2 of x plus log base 2 of x, right? And if I've got 4 of the same things added together, that's multiplication, right? Multiplication is repeated addition, so that could be written as 4 log base 2 of x. However, you can see how it is easier to have a separate rule for this so that we don't have to do that every time there. So when we have exponents, they can be pulled out front. It's an extension of that product property is what it really is there. So some examples, if I have log base 2 of 5 times x, it can be written as log base 2 of 5 plus log base 2 of x. If I have log base 3 of y over 4, I can write that as log base 3 of y minus log base 3 of 4. And then if I have log base 7 of 3 to the x power, I can pull that x out front there as my power gets pulled out front as the coefficient. All right. So there are two things with these properties that you are going to be asked to do. For some problems, you will be asked to combine these all into one log. In other questions, you will be asked to take a single log and split it out into multiple logs for that. So those are the two basic things that we're going to do. What is different about how AP does this versus what I used to have to teach is what they also want us to consider is they want us to consider what this means as far as like transformations, which is a pretty cool twist to it that I did not used to do. I like that they put that in here because it also helps us review those transformations in with this. But we'll see those when we get to it. So if I have something, first of all, to combine logs, you have to have the same basis. So if I see something like this, log base 2 of x plus log base 5 of y, I cannot put those together. They have to stay separated. There's nothing I can do for that because I have different bases on my logs. So you're not really going to see that. You have to have the same basis to combine. So if I have log base 4 of x plus log base 4 of y, I can write those two together with a log base 4 of x times y. Okay. B is almost the same except for I have subtraction. So if I have subtraction, then that is my quotient property. So that'll be log base 3 of the whatever comes first goes on the top of your fraction. Whatever is second goes on the bottom of your fraction. So you'll have log base 3 of 5 over z. Now, these next ones have more than one thing going on for this. So that makes it a little bit more complicated. Whenever you do this, you want to go from left to right. Actually, you want to use the order of operations. So if there is multiplication, you would do that first. Then you would do addition and subtraction. In this case, everything's just subtracted. So you want to deal with these first two things first. So if I put those together, and this is the problem I was talking about, is it necessary for him to put that 10 there? It is not. Now, I imagine that Mr. Passwater, who is probably a better teacher than I am, because I'm telling you, like, I think half of all pre-calculus teachers are probably just using his stuff right now based on what the Facebook page looks like. So I'm pretty sure he knew that log base 10 was just log. I bet that he may have put that there to see if the student said anything about it or anything there. I imagine he had some intentions here. Normally we would not write the 10 on a log base 10 because that's the common log. So this is just going, we could just write it as log. We don't have to put the 10 because it's understood that it's 10. And that would be x over 5. And then I've got minus log of z. And now I would need to use my division property again. So that would be log of, now I've got x minus 5 is my first stuff, and I got to divide that by z. It is unlikely you will ever see an answer choice that has a complex fraction in it like that, fraction inside of a fraction. They generally do not want you to leave complex fractions in your answer there. So how do I divide fractions? Flip the second and multiply. It's easy as pie. So that second one's not a fraction right now, so I'm going to make it a fraction by doing 1 over z. Over to the side, I'm going to do x over 5 times 1 over z. And that is going to give me log of x over 5z. It's got to be x over 5z. But yes, if you don't show work for it, that's fine. Everybody good there? Okay. So, let's go to D. All right, what should we do first on this one? This one has two things we have to do. We don't have parentheses. So that 3 does not go with this expression over here. We do need to deal with that 3, though, because I cannot combine 2 logs with my product property if there's a number sitting outside of it. So something's got to happen to that 3. I cannot do that because this is not an equation. I don't have like an equal sign where I can do that on both sides. I'm going to use the power property. This number right here is the coefficient, so this gets sucked back in as your exponent. All right? So if you have any coefficients, you can suck them back in as your exponent. And so you're going to have log base 2 of x cubed minus log base 2 of y. And now you just have log base 2 and log base 2. You can use that quotient property. You're going to have log base 2 of x cubed over y. All right, so on E, we got 2 of those logs have coefficients in front of them, right? So we want to take this 2 right here. We want to pull it back in as an exponent. We're going to do the same thing with the 5. Pull that back in as an exponent. So I'm going to have log base 7 of a squared minus log base 7 of b to the 5th plus log base 7 of 4. And when you get down to addition and subtraction, you want to go left to right. So if I put these 2 together first, I'm going to get log base 7 of a squared over b to the 5th plus log base 7 of 4. And then when I have addition, that means I'm going to add. When I have addition, that means I'm going to multiply my 2 things that I'm taking the log of. What's the name of that? Argument, maybe? I don't know the mathematical name for the stuff you're taking the log of. Maybe argument. I need to look that up. Log base 7 of, you're going to be doing 4 times a squared over b to the 5th. So 4 times a squared over b to the 5th. You cannot do unless they're both fractions, but you can make that 4 a fraction by putting it over 1. So you will get 4a squared over b to the 5th. All right. Questions on those? Now, when I looked at these notes, I was like, he has messed up on F. We can't put that together. Because you got a 2, which does not have a log at all, and log base 6 of x. So, and it's not, like, if that was 2 times log base 6 of x, we could pull it in as an exponent, right? It'd be our power rule, but that's not the case. We've got 2 plus this, so I was like, this can't be done. Why did he do this? I think he shouldn't have put the plus there. But when I went and checked the key, I realized that I was wrong, and it can be done. So, for this, let's leave this alone right now, right? That's as simple as it could be. I need 2 to become something that has a log base 6 on it, right? So I need log base 6 of something to equal 2, right? Because I need 2 to be rewritten where it's got a log with a base of 6. So let's just put us a question mark right here because I don't really know what number goes there. Yeah. How in the world can I figure out what that question mark should be? Right. I can do, so to get rid of a log with a base of 6, I could do 6 to the power on both sides. I can rewrite this, right? So question mark should equal 6 to the 2nd power. So that question mark is 36. So log base 6 of 36 equals 2. So if I rewrite my 2 with a log base 6 of 36 plus the log base 6 of x, now I can put those together. I could use a product property for that. And so I will get log base 6 of 36x. Now, let's stop for a second. I want us to think about if those were equations, right? So, why? Because I'm trying to think of why in the world would we ever even want to do that, because it seems like it is not going to be that helpful in a lot of cases. There are some equations they could ask you to solve where it might be helpful. If I think about this equation, 2 plus log base 6 of x, that is the log base 6 of x equation and what has happened to it. If I got a plus 2, what's that do to a graph? Oh, is it up or is it left? It's going to be up because it's not inside of the parentheses with the x. So this would be a log equation shifted up 2, right? It's equivalent to this expression. This is not a log equation shifted up 2, right? What is this? If I've got that 36 on the inside, what's that do? Yep, horizontal compression by 1 over 36. So, like, just so we can kind of see what is happening there, let's look at this on Desmos. If I do y equals log base 6 of x, that's like the parent function we're starting with, right? So if I do y equals log base 6 of x, I'm going to put plus a here so you guys can see what happens, right? If right now we're right here, as that goes up to 2, that graph ends up right here. So that is our log base 6 of x plus 2, or the 2 can be at the front. If I do the same thing, but instead of putting a plus a on the end, I put a b on the inside, and I'm going to have to adjust this right here a little bit. Let's see, let's go from 0 to, I need to go 0 to like 50. Let me go by. Alright, I'm not going to be able to get this one quite as exact just because of the 1/6 of the fraction thing. But notice what happens. Like, as I make that b bigger, what it's doing, right, is it's a horizontal compression. It's squishing it in this way. But if I had just done this on the graph, it just looks like it's moving up, right? So those two transformations are equivalent to each other. And if I get all the way up to 36, actually I can get exactly there. If I go all the way up to 36, if I can get there, then I would get to that exact same thing. That's just sort of like a visual representation of what we're seeing happen here. I think it's kind of cool that he brings that back in here, or AP, I guess AP has it in there for us to do that, because it kind of takes, usually I do all of this stuff with no like context at all, but this kind of brings back in those transformations to do that here. Alright, so the other thing that you might be asked to do is you might be asked to break it back apart. Okay, so if I have log base 3 of x squared over y, and I want to break that back apart, I would start this one with subtraction because I've got a division here. So I would do log base 3 of x squared minus log base 3 of y. But is that an answer choice? It is not. So they want me to do something else. What else can be done here? That 2 can go to the outside. We'll have 2 log base 3 of x minus log base 3 of y. Which one's my correct answer choice? C. All right. That 2 doesn't go with both of them, just with the first one. Okay. All right, so here's some more with that dilation. So f of x equals log base 6 of x is a horizontal dilation of the function g of x equals log x. Show that f can also be written as a vertical translation of g with f of x equals g of x plus k, where k is a constant. So this is asking us to write it where we just have like a log x plus a number over here. So this is like what we were just doing earlier. We need to break this apart. So if I break it apart, f of x is going to be log of 6 plus log of x. Now, this stuff right here, log of x, is g of x, right? They're asking us to write this as f of x equals g of x plus k. So I could write that log of x first. I could write it like this, f of x equals log of x plus log of 6. So if I do that, what is my k? What's the constant k? It is log 6, because that is a number. That is not a variable expression, all right? Our k would equal log 6. It's always hard for students to recognize log 6 as a number, because it doesn't look like a number, right? It looks like a variable expression, but log is an operation. If you go to your calculator, here, you can go over here and you can type in log 6, and it's going to give you a decimal, right? So this is the same as having log of x plus 0. What was that number? 77815. So log of 6, or if they give you the decimal approximation, it could be the decimal. They'll probably give you log 6 though. Is our value. So that is a shift up log 6, or up 0.77815. So you got to recognize whenever you break these things apart, if you are left with a log that doesn't have any variables left in it, that is just a number. It's a constant. It's a complicated constant, but it's just a constant for that. Okay, 4 is another one that I had to stare at for a little while. Is it 4 or is it? Yeah, it's 4. I had to stare at this one a little while and go check the solutions to figure out what to do on this. But now that I see it, it's kind of cool too. I taught you guys the change of base property the other day, just so you could type it into your calculator that way if you wanted to, right? So if I've got log base b of x, I can write it. Now what I told you guys is log, can't write there, log base b of x equals, I just did log of x over log of b. And since I don't have a base on those two logs right there, what was the base on that? 10, right? I also told you if you wanted to, or I think I told you anyway, that you could do natural log of x over natural log of b. It doesn't really matter which button you use, because I was teaching you calculator shortcuts. So I wanted you to either use the log button or the natural log button, because both of those have their own button on the calculator. But the fact is that you can use any base. It could be 10, it could be e, if you want it to be, right? Or I could use a completely different number altogether. I could use 5, I could use 7, I could use 15. Whatever number you want to use. So let's look at this question. f of x equals log base 4 of x. G of x equals log base 9 of x. Show that f is a vertical dilation of g by finding the value of k such that f of x equals k times g to the x power. So they are asking us to show that if I take some number right here, if I do log base 9 of x and I multiply it by some number right here, that it would just be the same as f of x. It would equal the f of x, which is log base 4 of x. So we are starting with log base 4 of x. We want it to equal some number times log base 9 of x. And there's nothing to split up there, right? We can't use a product property. We can't use a division property. There's no exponents to be pulled outside. There's nothing you can do. Somehow, I want to change this log base 4 into a log base 9, though, right? So, I can use the change of base formula, and I can use the base of 9. So, if I do that, when I told you to do it in the calculator, I would have told you to do log of x over log of 4. But we want to change this to a base of 9, so I'm going to put a 9 right here. So if you look now, we have log base 9 of x, right, which is our g of x equation. What is log base 9 of 4? 9 to some power equals 4, and so it's that power, and you could find a number for that. You'd need the calculator, but you could find a number for it, right? Or I could type into my calculator however you want. Like if you want to use the math button and do that log base, I could type in log base 9 of 4, and it gives me just a decimal, right? So this part right here is just a number, right? So would it be okay for me to write it like this? 1 over log base 9 of 4 times log base 9 of x. Is that equivalent? Okay. If I want to put it back, let's think about putting it back together to see if it's equivalent. If I want to put it back together, I need them to both be fractions. I'd have to put this one over 1. I would multiply the top together, which would give me log base 9 of x. I would multiply the bottom together, which would give me log base 9 of 4. So it's equivalent to write it this way. All right, I'm going to erase that over 1 because we don't really need it right now. Oh, gracious me. All right, so what I've got here is I've got this times this stuff, which was g of x. 1 over log base 9 of 4. Does it have any variables in it? It does not. That is a number. It's a complicated number, but it is a number. If I want to type it into my calculator, I can. 1 divided by log base 9 of 4 is going to give me 1.584962,501. So that's a number, right? So essentially what I've got here is 1.58621, whatever that was, log base 9 of x. So k is that number. You're probably going to see them call it 1 over log base 9 of 4 instead of the decimal, but it could be 1 point. It was 496. It wasn't even close to those last numbers. 4, 9, 6, 7, 1.5846. Right, so that would be your k value. So that change in the base is really like stretching it out up or down for that. Everybody okay here? He in his notes did not introduce natural log function earlier, so he's introducing it right here. I talked about that whenever we did that earlier, so you have already seen that natural log. So the last question we have here is just asking us to express this all together. I cannot put these together yet because I got a 3 and a 4 out front. What should I do with those? Move them in as exponents. So this goes back in as an exponent, back in as an exponent. So natural log of x to the third minus natural log of y to the 4. And then, since I've got subtraction, what does that become? Division. So that is going to be natural log of x to the, oh, wait, I'm writing that wrong. About to do. It's going to be natural log of parentheses x to the third over y to the 4th. Like that. So A would be your answer for that. There's like 3 types of questions you might be asked from this. One will be that I give you like a log that's all spread out in several different logs and you're putting it all together. The second one would be that I give you a log that's all together and you're separating it back out. And the third type of question I might ask is like those 2 that we're talking about, those transformations for that. And you'll see a little bit of all of that on the assignment that you guys will have today. So we have finished in pretty good time today. You got about 20 minutes to work on your assignment.